Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 2 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have this exponential function, and we simply need to find which statement is best represented by the graph. And so what I'm going to do is I'm just going to kind of leave it down here. The very top is cut off, but we just know that it keeps kind of moving over to the left. All right, so let's look at our statements. We simply need to evaluate them, find the one that is true. So the equation of the asymptote, okay, so that's a term that we need to know, is x equals 4. All right, so what does that mean first off? Let's graph x equals 4. So if x equals 4, that means every single time we think of a y value, the x is going to be 4. So if the y is 5, the x is 4, y is 6. So we can draw it as a series of dots. Really, x equals 4 is a continuous line that goes vertically through the 4 value for x. So that's what x equals 4 is. Now, is that the asymptote? Well, the asymptote is the point that, or the line that the function approaches but never reaches. So these types of graphs are going to have a curve, and it kind of curves out to the left, and it kind of curves right here, and that is going to be what we're looking for there. But never, let's go ahead and finish this, but never reaches. Really, it's not so much a point, but we're going to say a line. And so, no, it reaches that because it crosses right through 4. So this is not correct. But what is the asymptote? Well, let's change colors here. If we look at how it's going up here, it's going to keep going left forever. It's going to keep going up a lot faster, but if you extend it to infinity, it's going to keep going left. So it's not over on the negative side. But your basic function here, look at this line right here. If we were to extend this out for forever, what we're going to find is that it's that x-axis, y equals 0. This line is going to continually get closer and closer and closer and closer and closer and closer and closer. And if you're graphing this on Desmos, you would zoom in and zoom in and zoom in. It would never reach 0. That's my asymptote. So that is why this is incorrect, because they've identified the wrong line as the asymptote. All right, so B, the function is increasing as the interval is x equals 0. So x equals 0 is right here. I'm going to make this green. X is greater than 0, or x is greater than 0. Is it increasing? No. The function is not increasing. It's actually decreasing. It's getting closer and closer and closer to 0. And decreasing as the interval x is less than 0. Well, x is less than 0 is over here. And look, it's increasing right here. So that is opposite. If you could flip these two, you would have a true statement. But that is going to be incorrect. All right, the x-intercept of the graph is 8, 0. Well, we don't know because 8 doesn't exist here. But if we were to say that's 4, 5, 6, 7, 8, I've already said that I think x equals 0 is going to be my asymptote. So if that's the case, there is no x-intercept. So I'm going to say probably not, because I believe our asymptote is going to be x equals 0. We can't verify by visually looking at it because our x-axis doesn't go that far. So let's check our D. The y-intercept of the function is 0, 3. Well, they should have put that one first because that's exactly where our function crosses the y-axis. That is correct. So this is not going to work here. And our answer is going to be D.